All right, let's talk about a huge headache in cybersecurity, something that's been a problem for years, the fact that none of our security tools speak the same language. Today, we're going to break down the solution that's gaining massive traction. It's called the Open Cybersecurity Schema Framework, or OCSF, and it's all about creating a common language for our security data. Let's dive in.
Okay, so here's how we're going to break this down. First, we'll get into the weeds of the data chaos that security teams are dealing with every single day. Then, we'll introduce OCSF as the answer to that chaos. We'll pop the hood to see how it works, look at a real-world example of it in action, and then wrap up with a big picture. Why this is so much more than just a tech fix. It's a real game changer.
All right, first things first. Let's talk about a problem that anyone in security or DevOps knows all too well: the absolute tangled mess of security data.
I mean, think about it. Every single tool in your security stack, your firewall, your endpoint detection, your cloud logs, they all have their own unique way of talking. They're all generating logs in completely different proprietary formats. It's like trying to make sense of a dozen conversations happening in different languages all at the same time. It's just total chaos.
And you know, this chaos isn't just an annoyance. It has real, serious consequences. You get locked into vendors because moving your data means rewriting all your analytics. Your engineers, they get stuck on this endless hamster wheel of writing and fixing fragile, custom parsers every time you add a new tool. But here's the kicker. When an actual attack is happening, your security analysts are wasting precious minutes, sometimes hours, trying to piece together clues from all these different data formats. It's slow, it's expensive, and frankly, it's dangerous.
So how do we fix this? How do we untangle this web? Well, that's exactly where the Open Cybersecurity Schema Framework, or OCSF, comes into the picture, ready to bring some serious order to all that chaos.
So what is it? Put simply, OCSF is an open source standard. Think of it as a shared blueprint for how to structure security data. And the most important words here are open and vendor agnostic. This means it doesn't matter if the data is coming from AWS, CrowdStrike, or your firewall. With OCSF, it all gets organized in the exact same way.
Really, the easiest way to think about it is as a universal translator. It's like the Rosetta Stone for security logs. Instead of everyone shouting in their own data dialect, we all agree to speak one common language. And this simple, powerful idea has massive implications. And here's the really important part. This is so much more than just a data cleanup project. Adopting OCSF is a strategic move. It's designed specifically to help you break free from vendor lock-in. It allows you to build a stable, long-term security data lake where your detection rules and analytics are portable. You write them once and they work no matter which tools you're using, today or 5 years from now. Okay, so let's get into the mechanics of it. How does OCSF actually take that messy pile of raw logs and transform it into clean, standardized data that you can actually use? The whole framework is built on a few key ideas, kind of like building blocks. You have high-level event classes for things like network activity or authentication. You have common entities, so an actor is always an actor, a device is always a device, and so on. And it uses enumerations, which are just constrained lists, to make sure a value like blocked is always written the exact same way, which is absolutely crucial for automation. So the actual process from start to finish looks something like this. First, you ingest the raw, messy log from whatever source. Then, a data pipeline maps the fields from that raw log over to the OCSS standard. This is also the perfect time to enrich the data with more context. And finally, that clean, standardized, beautiful event gets sent to your SIM or data lake, ready for action.
And this right here, this is where the magic really happens. You see that a field like source IP from a firewall log always gets mapped to actor.ip. A user ID becomes actor.user.ui. This consistency means your queries, your detection rules, your automated responses, they become totally portable. You write them once, and they work everywhere.
Okay, theory is great, but is anyone actually using this? Does this work in the real world? Oh yeah. Let's take a look at a real-world data pipeline. A fantastic real-world example of this in action is the integration between a tool like Crib, which is an observability pipeline, and Amazon Security Lake, which is a service built from the ground up on the OCSF standard.
So here's the flow. You've got raw logs coming from, say, a Palo Alto Networks firewall. They get sent to Cribble. Inside Cribble, a pre-built pack automatically maps all those raw fields to the OCSF network activity schema. Then, Cribble writes that perfectly formatted data straight into Amazon Security Lake, where it's immediately ready for analysis. No custom parsing needed. It just works.
Now, the really crucial thing to get here is that this isn't a one-trick pony. The exact same pipeline can take data from CrowdStrike, from Azure, from SentinelOne, from dozens of sources, and normalize all of it into that single queryable format. This is how you finally truly break down those data silos.
So we've covered the what and the how. Let's land the plane with the most important question of all. Why? Why does adopting a standard like OCSF give your organization such a massive strategic advantage?
I mean, the transformation is just night and day. Before, you're dealing with fragmented data, fragile pipelines, vendor lock-in, and slow investigations. After, you get a centralized security data lake, portable analytics, real architectural flexibility, and the result of all that? You get faster at detecting and responding to threats, period.
And you know what's great? Pretty much everyone in the security org wins here. Your SOC analysts can pivot between data sources in a flash, making their investigations way faster. Your architects can finally design clean, resilient, future-proof data systems. And your leaders, your CISOs, they get the freedom to choose the best tools for the job, not just the tools that happen to integrate with their current ecosystem.
And believe me, this is just the beginning. OCSS is part of a much bigger movement toward open standards in technology. We're already seeing it start to converge with observability frameworks like OpenTelemetry. Just imagine a world where you can seamlessly correlate a security alert with application traces and infrastructure metrics. That's the future we're heading towards. So really, it all comes down to this one question. As security becomes more and more of a data problem, having a common language isn't just a nice-to-have anymore. It's quickly becoming a fundamental requirement for building a truly scalable and resilient defense. It's about getting your data